Hello and welcome everyone. I'll be jumping on to another problem. This problem is called the array cloning technique. Um, so in this problem, simply you're going to be given an array of n integers. And you can apply two types of operations. At the end of the day, what you're going to have to do is find the minimum number of those operations needed or required such that you get an array having all the elements equal to 1. Having all the elements which will be equal. So every element of the array should be equal. You have to reach that state. In order to reach it, you can apply basically two types of operations here. What are those two operations? Number one is you can choose any array, and first you would choose any array, and then you would clone it. Clone it means completely copy that array. So you have two of the same arrays, and then after that, what you can do is you can simply swap elements, two elements from any two copies on any other positions. What it means is basically they have actually given a sharp example here in the case here. Let me take a look at it. Here we go. In this I guess it's the second test case. The answer is 6. So you would see that minimum 6 number of operations are required in order to get all the elements are equal. How they are actually approaching this. For example, they applied the number 1 operation, meaning the cloning the complete array. So we have two arrays of equal elements. But we have to reach such a state where any of these array should have all the elements equal. And in order to reach that, only applying one operation, the first operation, is not going to work. We're going to have to move further. What they did here, they swapped elements. How did they swap? They swapped elements with this 3, double 3, 3, 3 with 0 and 0 of the next. And after doing that, what happened? I think back to back they did, I guess, yeah, they did two operations back to back. As you can see, 0 and 0 is being replaced with 3, 3. Of this 0 and this 0 is being replaced with this 3 and this 3. And after that, we get this. Now we're slowly moving towards the final array where all the elements would be equal. And you would see that in this array we have 0 having 4 frequencies, so it would be obvious to copy this array and not this one. So this is just, you won't be using it anymore. You care about this one because you want the array to have equal elements as quickly as possible, applying the minimum number of operations, right? That's exactly why you would apply the copy array operations again here. And as you can see, we have copied, and after copying this, they did again. They did swap it. How did they swap? This 3 would probably this 0 with this 3, and we get the 0. Just like that. And similarly, this 3 would get one of the zeros would get replaced with this 3. So you get all the 0 at the end of the day. And finally, we can say that the total number of operations is 6. How it's 6? Here's the 1, and here 2 swaps operation has been applied here. So 1 plus 2, 3, and then number 4 because the array copy. And then 5 and 6, 2 swap operations have been placed, and thus getting the final array. Now the big question, how are you going to be able to solve this problem? Now in order to solve this problem, I've compiled 2 scenarios that could happen. What are those 2 scenarios? We're going to have we're gonna take a look at those two scenarios in here. The first one is we are actually going to divide the array into two different groups. Now, what will be the name of those two groups? One group that I'm naming is the element which is appearing the most of the times, the element which has the highest frequency out of all the elements of the initial out of all the elements of the array itself. So for example, you could say that M is that element which has the frequency which is the greatest than any other element here. So I mean, in terms of numbers, you could call it like that, okay? But I just wanted to put this in a much more general way, and so I did this. And so what happened here, M, and X1. This is one possible race. This is one possible scenario that could happen. What is that possible scenario? Okay, first of all, what are the two groups? One group is that we have M, which is a value that is appearing the most of the times than any other value of the array itself. That's it. That's the value that I am referring to as M. Now, what is X1? X1 or X2, it could be X3, there could be X4, whatever. These values I am referring to as the rest of the values. I don't care about, the rest of the values, I'm giving them a name as group X. Having X1, X2, X3 does not matter what they are. They are just part of a team called rest of the values. And why I am so curious about the number M, because that number is appearing the most of the times. That number is having the frequency the highest possible among any other individual numbers in the initial array. Now we're going to talk about the two different scenarios. The first scenario is being displayed here, where that M number, M, its frequency would be greater than the rest of the value's frequency. Do you understand what I'm saying? If there is a number, like what if the example, let's take an example to make sure that you understand it more. Now, for example, in here, what is M? M is the value 1. Why? Because its frequency is the most compared to the individual values of the initial array itself. And what are these? These are called the rest of the values. I could call it X. Even more, I could call this 2 as X1, this 3 as X2, this 4 as X3, right? So that's how I could, define it. But in this case, the scenario that I am taking here is where this M number, this M value's frequency is less than the total X frequency, which means, let's take an example. In this case, what is the frequency of X? It's 3. What is the frequency of M? It's 2. Similarly, in this case, what is the frequency of M? It's 2. Right? It's 2. Frequency of M is frequency. The frequency of M is 2 here. And the frequency of the rest of the values, what are those? It's 1. Now, the condition that I am talking about is whether the scenario, what's the scenario? If this FM value is greater than or equal to, if this FM value is greater than or equal to Fx, which means if the frequency of the element that is appearing most of the times is greater than or equal to the frequency of the rest of the values. Frequency of the rest of the values. If it's less than f of m, less than or equal to f of m, or you could call it f of m is if f of m is greater than or equal to f of x. This is the case. In this case, what would be the answer? Now, our goal would be to maximize, our goal would be to appear, in such a place where each and every element is equal, and I want to do it as fast as possible. Now, when I have a case where my f of m is far more greater, I have a chance to do this quickly. Because my frequency of m is greater, I would always lock on this array where m is greater than m's frequency is greater. So what I would do here, I will apply one operation, which is the copy operation. If the array's scenarios format is like that, I will copy that. After that, what am I going to do? I will check how many m I require. In this case, I require only one m. And then what I would do, I would simply swap it. Swap it with the m of the copied one will be swapped with the x of the copied x of the original. You could call it like that. Right? So if I take a real example, now after swap it, you get MMM. So you get the point. The answer would be 2 here, I guess. One swap and one the copy operation. If I take a real life example, I think that would suffice it. That would, that way you would understand it more, I think. Let's take one big simple example like that. Let's say this is the array. And you know that this is m, right? M, and this is x1, this is x2. In total, this is x, frequency of 2. Of course, it's greater, so I have a shot to do this quickly. How am I going to do that? I'm going to copy this array. 1, 1, 1, 1. So 2, 3. I have a copy. Now, what am I going to do? This one, let's just swap it with this 2. This one, let's swap it with this 3. Right? That's how we're going to get it. It only took like 3 operations to make it. That's exactly what we do if we have this type of scenario. Now, what's the other type of scenario? It's the opposite one. It's the opposite one, which means if the f of x, if the f of m is less than the f of x. It's the opposite of the previous scenario. Now, in this case, you have to do a little bit of a work. Because in this case, what you have to do is you have to perform in the same way that I talked about in the previous scenario until you reach a point where you have the f of m greater than or equal to f of x. So until your m's frequency is greater than or equal to f of x, you would have to apply the copy and then swap. Now, what would generally happen in this scenario? How the operation overflow is going to work? We have this simple example here. Let's say we have m of 1, and then x1 and x2 could be any number. Let's talk about that. Let's just imagine that it's the rest of the values, okay? As we've talked about. Now, what am I going to do? I'm going to copy. So here's the copy one, and I'm going to do this m. I'm going to copy this m and boil it here. I'm going to swap it, this m with x. Then after that, what I have is mmx. Now, when I have this m, and x, now what am I going to do? I'm going to copy again this mmx. Now, do you see something similar that's happening here? because it's the same formation that we talked about just before when we were talking the previous scenario. We had this formation, right? And we said the answer would be like that. That's exactly what I said. I will, if the frequency of m is less than the frequency of x, then up until it's greater than or equal to the frequency of x, or should I call it the frequency of the rest of the values, I will keep on going. I will copy and I will add those values. But what would generally happen in this case until, you see, the case that I'm talking about, what would generally happen is, as you know, that f of x is greater and f of m is less, but your target would be to reach greater than or equal to level, right? Now, in this case, you'd copy and you would add, I guess you would add f of whichever is the minimum one, meaning the frequency that is left. Let's just okay. Let me take a look at the code section. I think that we would understand more what I actually wanted to mean by wanted to explain. So yes, we are taking values here. Okay, I actually sorted the array because I wanted to calculate the value m, the value which has the maximum count. And after that, what I wanted to do was, you see, that's the maximum count, that's the f of m that we talked about, and that's the rest of count, that's the f of x. Now, until it's greater than or equal to the rest of the count, what am I going to do? Result equal to 1 plus maximum of count, meaning the frequency of the value that appeared the maximum. So it would be 1 plus f of m. And this one, what do you think this one is? This one is actually the copy operation. And this mx of c and t is actually the swapping operation. So after doing this, you would the updated value with the highest frequency, updated value of f of m would be mx c and t plus equal to mx of c and t, right? Now, until you and after you calculate, you also update the rest of the count. The rest of the count is going to reduce, of course. When this value upgrades, this value also reduces from n. And this operation keeps on going on and on until you reach a point where it's greater than or equal to rest of count. Now, one additional check you need to do is you have to check whether the rest of count is not equal to 0. If it's equal to 0, there's no reason to do any other operations. If there is a rest of the count, then what you would do, simply do the operation that we talked about in this scenario, which is 1 plus the rest of the count. And finally, you would output the answer. So I think it was a pretty long video, but I hope it's worth it. And I hope you did understand it. Thank you very much.